Okay. In trigonometry, which is called the measure of triangles, because trig, that word means triangle. Meter means measure, so it's the measure of triangles. They have some very important ratios that are always true for all triangles. These are all right triangles. Again, this is always for right triangles. Okay, so basically I have to start with drawing a picture of a right triangle. We have to learn how we label a right triangle. Okay, and usually it's like this. You go A, B, C, where C is the hypotenuse. Okay, so C is always the right angle. This is how we typically label them so that when I use these formulas, they work for every right triangle. Okay, across from the angle A is side A. It's a little a, but it's the measurement of the side. Okay, the side length. Okay, so this is the side length. So is C. Notice that C is across. It's the hypotenuse, which actually this fits in with, if you think about a squared plus b squared equals c squared, that's how we write it too. So this is b, which is our other, I should call it length. Notice that B is always across from angle B. So each of the sides is across from their corresponding large letter angle. Okay, they don't make up. So letter B is across from angle B. It's really how wide is angle B. If I were to go up here along here, it's how wide it is. Okay, angle A is how wide angle A is. Notice this is a bigger angle here than B, so B is shorter than A. The correspondence on that is the larger the angle, the bigger the side. Okay, the smaller the angle, the smaller the side. Okay, so what we talk about is ratios of the angles. So all the ratios of the angles get special names. So this is called, let's say this is B. So we know that's angle B right there. So what we have is one, it's the tangent of the angle. Okay, so if I say tangent of angle B, it's going to be the side, let's see, now I just lost it. It's opposite over adjacent. It's B over A. So in that case, it's the opposite angle or opposite leg over the adjacent leg. Okay, because if you look at angle B, its opposite leg is over here. Its adjacent leg, that's the hypotenuse, this is the leg. So the leg that makes up part of angle B is the adjacent one. That's B over A. This tangent number will always be the same no matter if all the triangles, because triangles are similar, this ratio will be the same for all similar triangles that have the same measure of angles. So if they're similar triangles, right angles, the tangent number will be the same for all of them. Okay, so we usually call it the tangent of the angle, and I don't want to say it with letters right now. Usually what we do it is that, it's called theta. That's just a symbol for an angle right now. Okay, so this is just kind of like it's a Greek alphabet letter. Okay, and it just symbolizes an angle measurement. And we are going to use degrees. So right now, when you're working with this, you're going to see stuff on your calculator. You're going to need to make sure you're in degrees, not RAD, which is radians. Okay, radians is a different way to use measurements of angles, but you have to know if you're in radians or not. Okay.
What's that symbol called?
Theta.
Theta.
This is theta.
I thought you said theta. I'm like, that looks like theta.
It's theta. Theta.
Wait, you just know the Greek alphabet.
Yes, I do. So,
This guy's just good.
I give up.
my mom said,
I only know the Greek alphabet that pertains to math. I only know that.
Theta, alpha.
That's cool.
Alpha, theta, pi, phi, sigma. I think sigma's part of it. Okay, let's keep going.
No.
So it's the opposite
Not.
leg over the adjacent. Okay, so that's the ratio. Okay, so there's a couple ways we can use this ratio. Okay, let's take an example. Let's say I have this right triangle. I know that this angle here is 40 degrees. Okay, we're going to call that, we're going to call that B right now. This is C, this is A. And I know that this side is, let's do this side. This side is 10, okay? So all I know about this is one angle. Actually, I know two angles, right? Don't I know all three angles if I know one? Does everybody agree with that? You can find the third angle if I give you two, okay? So I know that this is 10, okay? I can find this side because I have an angle. So this is tangent of 40 degrees, because that's, remember, that stands for the angle, the degrees of the angle. So theta is my degrees of my angle, which equals the opposite leg, which is x. See the opposite leg of B? The opposite of B is x. Over the adjacent leg, this is my adjacent leg because this is my hypotenuse. Okay, so this is my adjacent leg of 10. I can then find out x if I plug into the calculator. This one you have to use your calculators. If you plug in tangent, they're in here.
Answers your
Make sure you put a torch down.
Okay, so let's see, I have to clear everything.
I was already in degrees. I
Good.
think so.
Look
Is it
on your,
default
so
to
on
degrees?
this one,
You hit DRG
on
and then
DEG
go to DEG.
or DRG, yeah, DEG.
Is-
Okay, so this one shows degrees right down here on the 30x,
Thank you.
which is what I said to buy for this class. Yes,
So there's DEG.
yes.
There's rad. But there's
You
also
don't want rad.
GR.
That's gradients. We're not in that one either. So you want DEG. So when we're using this, you need to make sure the calculator's on DEG, and it shows you DEG right at the bottom. Okay. So then you hit the tangent button. See where it says TAN? It says tan. Oh, by the way, tan is short for tangent. Okay.
What is tan? Oh, negative.
Tangent is the ratio. So tan is a ratio of sides. That's all it is. It's the ratio of sides for this degree angle every time. So if I put tan of 40 and hit equal, I get something like this. This is the number, 0.839099631 equals x over 10. Okay, I can put this in my calculator. It's going to tell me what the ratio should be because every 40-degree angle is going to have the same ratio. Now, it doesn't give you it as a ratio, it gives it to you as a decimal. Okay, there's the decimal. Okay, so how do I find the length of x now?
Divide that by 10.
When divided by 10, what would I do with it?
Multiple.
Multiply, because this is a division. The opposite of division is multiply. So I multiply both sides by 10. That tells me that my value here is going to be about 8.4 approximately. Okay, does that make sense? Because if I take 8.4 and divide it by that, I'll get 8.4, which is very close to this. Okay, so I get that same ratio back again. Okay, so that's one way we can use it. So it's very easy to put in the tangent value. Whatever we have here. Now, it works a little bit. What I would suggest, I'm just going to make a suggestion. Always do the tangent so your missing side is up above, and then you always multiply. Okay? And so you can flip those around. Now, another thing you can do, is let's do one over here.
Don't do it.
Now, sometimes we give you two sides. Sometimes I give you two sides. I don't give you the angle measurements.
Pythagorean theorem.
Yeah, I could find this side by Pythagorean theorem, correct? Okay, but I'm not asking you that. I want to know what angle B is. I want to find out what angle B is. Well, I have the opposite, no, because they're not drawn to scale. No. I have the opposite side, right? Over the adjacent side, you see that? The opposite of B. So I know that the tangent of angle B, which I don't know what it is right now, is equal to 7/11. That's the ratio I know the tangent of B equals. Because all I did was say opposite side 7, adjacent side 11. So this angle, the ratio of this angle for tangent is this. How do I go backwards? Well, if you look at your calculator, especially if you have the 31, above tangent of a number is a tangent with a -1. Tangent, -1 like that. So what you do is you put
Second.
second, hit that tangent with a -1,
Which is the tangent, but
yes. Then hit 7 divided by 11, because this is our tangent, right? We're actually going to put the 7/11 in here, and it's going to give me the angle, the degrees.
32.47.
Yeah, so about 32.5 degrees. So that gave me this. I can now find this, and I can find the hypotenuse. I can find everything out about that right triangle. Okay, so it's using that ratio, and it's because all of these angles, all of these triangles are similar to each other. Because remember, if the angles are all the same, then the ratios are all the same. So this is just saying that when you have an angle of 32 here, the ratio of its opposite sides is going to be 7, or is going to be that amount. So that's what you're looking at in this. So we're going to learn tomorrow sine and cosine, which are the other ratios that go along with this. Okay? There's sine, cosine, and tangent are the three main ratios that are used in trig. Okay, you talk about them over and over. This is called inverse tangent, but it's really, you put the ratio inside and it gives you the angle. Okay, here you put the angle inside, get the ratio, and then use it. Okay, so know when you use, if you know the angle, it goes into tangent. If you have a degrees, put it in, because that's what that's getting you. Okay, questions on that? This supposedly recorded